Hello again. If you remember from the last time, my name is Dan and my goal is to create useful explanations to find correct answers for different type of chemistry related problems. So let's break some molecules together and let's look at our task today. I will try my best to give you the best explanation for this specific task. So let's read it out. What mass of hydrogen is needed to react with 3.18 grams of copper to oxide? For this question, we can use my 4-step strategy, and today we are going to learn it how to use it step by step. So step number 1. As we can see from the task, we have to write chemical equation. Therefore, reaction between copper oxide and hydrogen can be represented by the following chemical equation. So, copper oxide plus hydrogen forms copper and H2O. Let's look at oxidation state for each element by using information from the periodic table and from the given task. For the oxygen, oxidation state is 2 minus, and this is the state I would suggest you to remember because approximately more than 80% of time this will be the correct number. For the copper, oxidation state is 2 plus, and this is because of the name of the copper oxide in our task. So it means if you see Roman numerals like this, it stands for 2. I will not go more into details about Roman numerals because it is for another video. So let's look at hydrogen on the left side. Since hydrogen is single element, in different words, hydrogen is not combined with any other elements, and at this point hydrogen oxidation state is 0. Okay, and let's look at copper on the right side. Similar to hydrogen, copper is single element, so oxidation state for copper is 0 as well. And for H2O, oxidation state for oxygen is 2 minus. However, for hydrogen, this time oxidation state is going to be 1 plus. Because hydrogen is combined with oxygen, and hydrogen oxidation state 1 plus is very common, therefore this is something you should know without thinking. Once we have done this, of course, we have to balance out our chemical equation and to check if any subscript or coefficient is needed. If we have same numbers on either side, our chemical equation is balanced out and we can use it for our calculation. So let's check it. On the left side we have 1 copper, we have 1 oxygen, 2 hydrogens. On the right side we have 1 copper, 2 hydrogens and 1 oxygen as well. So it means we have same numbers on either side and our chemical equation is balanced out. Before we are going to the step number 2, we are going to write information inside chemical equation, what is given from our task and what we can get from the periodic table. Below copper oxide, we are going to write 3.18 grams. And this is the mass from our task. Above copper oxide, we will write molar mass of copper oxide. What is 80 grams per mole? Because this number we are going to use for our calculation in the next steps. Regarding to our task, we have to calculate the mass of hydrogen, and in this case, we will write below the hydrogen X, because X means this is something what we want to find, and above molar mass of hydrogen, of course, what is 2 grams per mole. Once we have done this, we can move to the next step, number 2. In the step number 2, we have to calculate amount of moles using equation where mass is divided by the molar mass, and this is what we are going to do. So we have all the data for the copper 2 oxide, and we can use this specific equation. So N for copper oxide is mass divided by molar mass. So the mass is 3.18 grams, and we have to divide this by 80 grams per mole. And we get 0.04 moles. And if someone is wondering how to remember the unit of this equation, just remember this. You have to cross out identical units in the equation like this. Think, think. And in our case, we have to cross out grams. And the remaining unit is the one that describes the result or the final measurement. What is, in our case, what is moles. So let's go to step number 3. And now we have to remember the main reason we balance chemical equation is to find the mole ratio. And in the step number 3, we have to use coefficients between substances. Remember, our main goal is to find the mass for the copper 2 oxide, and to do this, we are going to use coefficients from our chemical equation and amount of moles from the step number 2. If we look at our chemical equation, next to copper oxide we have coefficient 1, and next to hydrogen we have coefficient 1. It means the ratio between copper oxide and hydrogen is 1 to 1. And now we can write equation for number step 3. So N for hydrogen is, so as I said, we have to use the number from the step 2, 0.04 mole times 1 is 0.04 mole, and inside the brackets we can write the mole ratio 1 to 1. So remember, so we get this mole ratio from chemical equation, or in different words, we get this mole ratio from the step number 1. Okay, now we can go to the step number 4. So we have all the information about hydrogen, and we can use equation to calculate the mass of hydrogen. And mass for hydrogen is, we have to amount of moles, we have to multiply by molar mass. So we have 0.04 moles from the step number 3, and we have to multiply this by the molar mass of hydrogen, what is 2 grams per mole. And in total we get 0.08 grams. And that's it for today's problem. I hope you found this explanation helpful. Don't forget to subscribe for more chemistry related problems and tutorials. If you have any questions or if there is a specific topic you would like to cover, leave a comment below. So, bye bye.